Space is filled with terrifying things. Exploding stars, rogue planets, galaxies colliding. But there is one object so mysterious, so powerful, that even light cannot escape it. A black hole. If you fell into one, what would actually happen? Would you die instantly? Would time stop? Could you enter another universe? Today, we are going beyond the event horizon, into the darkest place in the cosmos. Every black hole begins with a star. Not ordinary stars like our sun, but giant stars many times more massive. For millions of years, these stars fight against gravity using nuclear fusion. But eventually, the fuel runs out. And when that happens, gravity wins. The entire star collapses inward in a violent explosion called a supernova. At the center, matter becomes compressed into an unbelievably tiny point. A place where gravity becomes so extreme that escape is impossible. This is a black hole. Scientists cannot directly see black holes because they emit no light. But we can detect them by watching nearby stars move, or by observing superheated gas spiraling into darkness. In 2019, the Event Horizon Telescope captured the first real image of a black hole, a glowing ring surrounding pure darkness, the edge of the unknown. Imagine traveling toward a black hole in a spaceship. At first, nothing seems strange. But as you get closer, space itself begins to distort. Stars behind the black hole stretch into glowing arcs. Light bends around it like warped glass. This happens because black holes don't just pull objects, they bend space-time itself. And then something even stranger begins to happen. Time slows down. According to Einstein's theory of relativity, gravity affects time. The stronger the gravity, the slower time moves. If someone watched you from far away, they would see your movements slow down near the black hole. To them, you would appear frozen in time. But from your perspective, everything feels normal. You keep falling forward, deeper into darkness. Eventually, you reach the most famous boundary in the universe, the event horizon, the point of no return. Cross this invisible border, and escape becomes impossible. Not even light can move fast enough to get out. Surprisingly, if the black hole is supermassive, you may not even notice crossing it. There may be no explosion, no sudden impact, just silence. The universe behind you slowly disappears forever. And at that exact moment, every message you send, every signal from your ship is lost to the outside universe. You are completely alone. But the deeper you fall, the deadlier gravity becomes. A black hole's gravity is so extreme that it pulls harder on your feet than your head. These differences are called tidal forces, and they begin stretching your body longer and longer. Scientists call this horrifying process spaghettification. Your body would become thinner than a thread. Bones tear apart, atoms separate. You are stretched into a stream of matter falling endlessly inward. In smaller black holes, this could happen before you even cross the event horizon. But in giant supermassive black holes, you might survive longer before the stretching begins. Not that survival matters for very long, because ahead of you lies something even stranger. At the center of the black hole lies the greatest mystery in modern physics, the singularity, a point where all matter is crushed into infinite density, a place where gravity becomes infinitely strong. According to Einstein's equations, space and time themselves completely collapse here. And this is where physics breaks. The laws that explain stars, planets, and galaxies stop working. Scientists believe two great theories of the universe collide here: relativity and quantum mechanics. Both are extremely successful, but inside a black hole, they contradict each other, which means we still do not truly understand what happens at the center. The singularity may not even exist the way we imagine, and that opens the door to terrifying possibilities. Some scientists believe black holes might connect distant regions of space. These hypothetical tunnels are called wormholes. If wormholes exist, falling into a black hole might not destroy you immediately. Instead, it could transport matter somewhere else in the universe, or perhaps another universe entirely. There is also a theoretical object called a white hole. A white hole would do the opposite of a black hole. Nothing could enter it, only escape from it. Some theories suggest black holes and white holes may be connected. Matter enters one side and exits another. But so far, there is no evidence these objects truly exist. Another mystery is even more disturbing: the black hole information paradox. According to quantum physics, information can never be destroyed, but black holes seem to erase everything forever. This paradox troubled physicists for decades, including Stephen Hawking. Black holes may seem eternal, but they slowly die. Hawking radiation suggests black holes leak tiny amounts of energy over time. Very slowly, they shrink. Over unimaginable timescales, trillions upon trillions of years, a black hole could completely evaporate, leaving behind nothing: no stars, no light, no trace it ever existed, only darkness. Black holes are not just cosmic monsters. They may hold the key to understanding gravity, time, and the true nature of reality itself. Somewhere beyond the event horizon, the universe may operate under laws we have not yet discovered. And perhaps the most terrifying part is this: nobody has ever returned to tell us what really happens inside. And maybe no one ever will.